Welcome, everybody. This is our session today on how Lockheed Martin builds software faster, powered by DevSecOps. Thank you all for coming. We know this is one of the later sessions in the day, so appreciate all the energy and all the enthusiasm you can muster for this session. We're going to have some question time at the end, and there's some mics, or there's a mic right there, and you can line up there for questions at the end, but let's get started. My name is Francis Ofungu. I'm the Global Field CISO at GitLab, and I'm here today with Alan Horn, who we're going to talk through their transformation journey and everything they've gone through from the before scenario to the successes and everything they've done so far in their transformation journey. And Alan, I'll let you introduce yourself briefly and tell us a little bit about what you do.
Thank you. Yeah, I'm really happy to be here. Thanks to all of you who took time out at the end of what is a very busy and full week. Here before we head off to replay this evening. I am the Director of Software Security, part of Lockheed Martin Corporate Engineering. Corporate Engineering is a somewhat small group that supports all of our different businesses. Lockheed Martin is involved in a lot of different spaces, including aircraft, surface ships, undersea spacecraft, and so, what we try to do is to help those software engineers across all of those different programs do a better job of developing and delivering software. My own background is software background, mostly U.S. Navy programs, and so I just, over the years developed a passion for, just seeing better and faster capability get out to our customers and help them accomplish their missions, and so I'm privileged to get a chance to do that every day.
Great. Thank you, Alan. So from just setting the scene, and we don't have to go through the agenda again, but just setting the scene, you have a very recognizable brand name, but not a lot of people here or watching remotely may know exactly what Lockheed Martin does from day in, day out perspective. So could you just set the context for the organization?
Yeah, so we, as you see there, a very large organization, 114,000 employees, and that includes geographically distributed in many different places across the U.S. as well as globally. We are the world's largest defense contractor. A significant percentage of our work is based on our relationships with the United States Department of Defense, but that runs the gamut. Everything from the picture that you see there with our space systems, where we're involved with Orion and some other programs that are extending the human spaceflight mission, to aeronautics, where we build the F-35 Lightning II, the Joint Strike Fighter, for the Air Force, the Marine Corps, and the Navy, missiles and fire control, and then rotary and mission systems, which includes Sikorsky, which has a marvelous history of helicopters. So in a lot of cases, right, like people may think of us as primarily a high technology company. We run real factories, we build real things, and that's important, and it is a significant part of our DNA. We've been around for over 100 years. We're Lockheed Martin only since 1995 because of the merger of Lockheed and Martin Marietta, but those predecessor companies go way back to the early days of aviation, and at the same time, over those years, software has become such a huge part of what we do. And so in many ways, we are also a software company, and that part of the work that we do, doesn't always get the same kind of press as when we build the next cool fighter jet. So one of my roles is to, give people a sense of, exactly what is it like to develop software at Lockheed Martin, like how do we, do that kind of work? How is it different from your normal run-of-the-mill commercial software that we see across much of the industry? So, just talking about that for a minute, the biggest thing that makes it different in terms of our software development is the nature of the systems that we build. They are very complex systems. We're often working in the real-time space, which means there's some element of our processing that absolutely has to be done on time. Receiving data from some embedded sensor, communicating if the pilot takes an action in the cockpit, making sure that signal gets out to the control systems so that the airplane is responsive. Those things go hand in hand with this idea of safety and mission criticality, right? So if we don't do that right, if we have software that's unreliable, or if we have software that isn't responsive, isn't performant the way it needs to be, then potentially someone's life is at stake, or somebody doesn't accomplish the mission that they set out to accomplish. So that drives a lot of the way that we think about software in terms of our ability to test it in order to understand exactly what it's doing, characterize its behavior in lab environments, in simulation environments, before we get it out into ground test or flight test kinds of situations. So a lot of that drives what from the outside may look like a slow approach. We have to be a little bit more methodical, but internally we try really hard as much as we can to iterate rapidly and provide new capability and get it past future end users, consistent with that need to be mission critical and safety critical security kind of software. The other piece is the environment that we work in. A lot of times our software is processing data that is either controlled for maybe export reasons or is classified, which means we have to have separate lab facilities to run that software. In some cases, the software itself maybe implements an algorithm that is classified, that we can't share the details with, or that that information can't be on any unclassified system. So from a software development standpoint, it's very challenging because it means that much of our software development has to happen inside an isolated, closed space that doesn't have internet connectivity. And that drives us in terms of how we develop software, and in terms of what someone will talk about today with the tooling. It really has driven us toward having to come up with some creative approaches in order just to have commonality in our software infrastructure.
And just given everything you said to this point, the mission criticality, the merger of two large firms coming together, and all the baggage that brings with it sometimes. And also just the objectives that you have where safety is the priority, safety is your number one priority. It's always interesting to hear you talk about that software process and the software architecture that powers a lot of those objectives. Because from my perspective, we see a lot of customers that go with this trial and fail error approach to sort of software testing. But the way you've described it, it sounds like you have to implement a lot of those systems in a manner that is safe from day one versus trying to bolt that in at the end.
Yeah, that's a very good observation. It's there are some parts of it that where we still can afford to have trial and error, or we can try something and then have it fail, but it needs to fail in a lab environment, or it needs to fail in controlled testing, as opposed to failing in the field. So at the same time, there are aspects of safety criticality, particularly around airworthiness or safety critical systems, that have to be built in from the beginning. If we end up with 100,000 lines of code and it hasn't gone through the necessary processes for safety criticality, it's prohibitively expensive to then go back and try and re-engineer that safety into it. So it does have to inform kind of everything that we do. And you can see on the screen because of the diversity of the products that we have, going all the way from spacecraft through aircraft to ships and subs, and then also missiles and fire control systems. I just didn't have room on the slide, but they're important too. We have a lot of different software baselines, many of which are very, very large, and they don't share a lot of common code, just because of the nature of where our companies came from, and because of the nature of the kind of software that they're building. So we're left with trying to find ways to bring commonality in where we can, while also recognizing that these kind of large programs with 20, 30-year life cycles, they just can't stop delivering new capability to customers in order to retrofit in a new architecture that everybody's going to adopt, or a new process for building and testing software.
Excellent. So we're here today to talk about a transformation journey. And with every transformation journey, there is that initial state, so the before state, where you decide we need to get better outcomes from how we develop software today. So can you just talk through that before scenario that drove that impetus for the transformation?
Yeah, absolutely. It's so as you saw in the previous slides, like right, Lockheed Martin came into existence in 1995, and it came about as a result of the merger of those two big companies, but also the acquisition of a number of smaller companies. We are very geographically distributed, like I said, in the US and globally, and so each one of those locations had its own legacy, it had its own history. In terms of software engineering and software development, that often meant that those individual locations had IT folks that were responsible for infrastructure, or it meant that the software teams itself, in a lot of cases, were shadow IT. And I've certainly, that was my role for the first several years of my career, was to essentially be shadow IT for an engineering program for the US Navy. And the consequence to that, of course, is we're spending money on each one of these programs on the physical infrastructure, on the system administration, on the installation of tools, their configuration. And just as a consequence, we were seeing thousands of individual configurations, thousands of individual code repositories, thousands of individual CI servers, mostly Jenkins, and because it was nobody's day job to maintain those things in many cases, we would see the natural thing that you would expect, right? It would be just good enough to get things into the lab to do testing. Once installed, it would be rarely, if ever, kind of updated with security patches and those kinds of things. And we recognized that as an organization, like that just wasn't where we wanted to be from a software or from a DevOps kind of standpoint. So we knew we needed to transform, but at the same time, because, like I said a moment ago, our programs can't stop adding capability, they can't stop making deliveries to customers in order to retrofit a new approach, and because we were still going to have those thousands of individual isolated environments, we had to take what I would characterize as more of a bottoms-up approach to that transformation, rather than, here's the corporate mandate that says, thou shalt develop software in this way.
No, that's a great point, because we hear a lot from the field and just in general that top-down approach, that leadership buy-in is critical to the success of a lot of transformations, and that could be true, but it's what you just described, that bottom-up understanding exactly what the front lines are facing from an engineering standpoint, and using that feedback loop to sort of connect what the leadership objective is as well. So can you talk me through what that process was like, creating that feedback loop from your engineering front lines?
Yeah, I think that's a great way to put it. I think it is really important to have top-down leadership pushing for transformation, pushing for improvement, setting business objectives. Like in our case, the speed metric for our transformation is everything. So it's, how much faster can we get from the time that the customer says, here is the new mission capability I need, and here is the funding to do it. How soon after that can we have that capability actually fielded and being used by the warfighter? So for us, though, while it is definitely true that you need leadership pushing on transformation, you need leadership encouraging that transformation, they're not always the best ones to identify the content of that transformation. So it's great to say we want to deliver faster, we want to shorten cycle time. It's not as easy for those senior leaders to be able to say, and oh, by the way, this is how you do it. So for us, it started with having conversations across our different business areas. We formed an organization that was intentionally cross-functional, that was, included software people, systems people, security people, test engineers. We formed an organization that spanned the different parts of our business, and we treated it as a collaborative opportunity to reach out to, I would almost say the people within our different business areas, within our programs, that were passionate about this kind of thing and the potential technologies. And then we said, okay, congratulations, you're early adopters or you're power users. And we said, what needs to be different in terms of how you do your job every day? And I think that was really powerful because while we couldn't necessarily satisfy all of the desires that each one of those folks had across the business, I don't know that we even maybe got a majority of everything that everybody wanted. they were able to see that they had a stake, that they had the opportunity to participate, and they were able to shape what we were doing, and they became our ambassadors to roll this out. I talked about corporate engineering being a small team. I work with another director who, together we ran the DevSecOps / software factory team, and we are 0.1% of all of the software engineers in Lockheed Martin, right? So the only way it was going to be successful was if other people went out and sold it and pulled it into their programs. And so that's kind of the approach that we took.
Perfect. Before we jump into the successes you started seeing with the execution of that plan you laid out, did you attempt the solution prior to sort of the GitLab, AWS combination of solutions? What were some of the things that you did, and can you talk about that and maybe why they weren't successful?
Yeah, so we went through what would be the traditional corporate approach of, let's establish a standard engineering tools review board. Let's have some people sit in a room and engage with vendors, and we'll pick a solution. What we generally found is that in that process, the needs of the individual software developer, were the first that tended to be overlooked. We need a product that will allow us to lock down the development lifecycle at this particular phase when we're going through formal testing, and so then that becomes a must-have requirement. Whereas just the collaborative kinds of needs that our developers had, the need to move fast in terms of the edit, compile, test loop, in terms of the branching, modify, merging loop, those kinds of priorities, well, those were important, but they weren't they weren't the things that we had to have for compliance reasons. And so, that was one of the biggest reasons why, I tend to emphasize the bottoms-up approach, because what we found is that we tended to have more success when we focused less on, from a corporate standpoint, what are our top-down requirements, and we tended to focus more on, what is the next iterative improvement that we can make from where we're starting today in order to get that much closer to what is our business objective.
And it sounds like operationally you had created sort of a catalog of reusable code that individuals could sort of deploy, but the collaboration was happening elsewhere on sort of a separate ecosystem. So that lack of harmonization between the catalog of assets and the collaboration sounds like what we hear, at least from our other customers as well, is that unified approach to collaboration and also asset and cataloging is one of the keys to driving that transformation success.
Yeah, I think so. We've, over the years, we've had multiple attempts to create, reusable code baselines, but they tended to be, here is a separate place that's different from where developers do their day-to-day work. Take your reusable code and put it there. And of course, what it ends up being is a, kind of a write once, read never repository, right? You put the code in there, close the box, and then, it looks good. Wow, look at we have 500 potentially reusable projects, but how many actually get reused? Well, don't ask, or maybe the answer is 3. So trying to find a way to do that collaboration across our whole organization in a way that was more focused on the community and also more focused on where the developer does their day job, I think was significant for us.
Great. So let's transition a little bit to your successes and when you started seeing some great return or great metrics from your transformation journey. Just walk us through that.
Yeah, so we had, like I said, when we came together and we formed our software factory organization, we had people from individual parts of our organization. And one of the things that was great about that was they brought solutions that had worked locally. And so, we started out saying, look, we don't know which of these solutions is going to be most advantageous, but it looks like this, potential approach could be something that people would be interested to adopt. So let's try to build a version of that at the level of the entire corporation, and let's see what the adoption looks like. And GitLab for us was one of those cases. We'd seen success in our space systems area. where they'd managed to move to the GitLab platform. They managed to encourage adoption for a number of their development teams. And we said, well, let's create an instance of it that we can manage from the Lockheed Martin level so that, the business areas outside of space will be more comfortable using it. And let's see where it goes. And it was timely because, we were starting to see the incorporation of integrated continuous integration, integrated CI into GitLab. And so what we were able to offer as a result is not just, here is a place that you can store code, here is a place where you can do merge requests, but also here is a place where you can actually do your builds, you can compile, test, and security scan. And oh, by the way, you can do it, because this was also around the time of our, where we really started to push into cloud incorporation. We could say, we have a scalable environment in AWS where those builds will happen. So you're not bringing your own build infrastructure. You're not bringing your own, your own test environment in order for those tests to take place. You can leverage existing standard container images and an environment that is set up for you and that scales automatically. And what we saw as a result of that was just almost immediately, just people wanted to be on the platform. We started about 4 years ago with just an internal conference, a virtual conference that we did, and one of the most popular demos was just one of our architects sitting down and showing going from 0 to a deployed Kubernetes solution in under 45 minutes. And I mean, you've all seen that demo, right? Like that demo is not uncommon in the internet world, right? In the internet connected world. But it is considerably harder to do that demo in the kind of controlled environments that we have to work in. And so, showing that it could happen there, and showing, it not only that, but you can use it right now. You can follow along, and you can be using it tomorrow for your team. I think it had a significant impact in terms of creating the buzz or creating that people wanted to be part of the community.
Right. So during this transformation, I'm sure you had some key metrics that you wanted to use as indicators of progress or indicators of success for what you were trying to build. Can you share a little bit about that?
Yeah, the first order metrics, I talked about, speed, kind of equates to cycle time. The rest of the DORA metrics were really important to us as our first order metrics. So, change failure rate, mean time to repair, and then deployment frequency. And I would say that latter metric of deployment frequency was the one that we measured the most, as people would make the transition from whatever was their existing tool chain to this new environment that we provided. We would say, like, what did you see as a result of that in terms of your ability to deliver? And at first, that is just deliver to a lab environment. We're not trying to solve the whole problem at once. If we're getting capability into the lab more frequently, we're integrating that capability into the broader system more frequently, then we believe that we're not only improving efficiency, but we're also significantly reducing risk of things not working right when they come together. And so that metric of deployment frequency was really key to us. Now, out of that, we also looked at, okay, what are the second order metrics that we think will help drive those first order DORA metrics? And one of those was definitely around how many people are on this platform. If we see an advantage for people moving to this platform, then we want to measure, like, how dramatic is that move. We also looking closely at just how active is this platform. We wanted to see a move from maybe the teams that built once a week or built nightly. They'd create an assembled build to deliver to the lab. Why can't we turn that into a, multiple times per day? Why can't we turn that into an automated deployment? If it's ultimately going to a classified environment, why can't we automate as much of that process as we can, so that the software is, the software is continuously moving into that classified space and continuously getting deployed to that lab environment. So, I think since we put this slide together, I think we're now, this may be a slightly older number because I think we're probably closer to 250K individual builds every 24 hours. It's the kind of thing that, from our perspective is great. I think there are some folks on our IT side that that look at the cloud spend numbers and ask us questions on an ongoing basis about the importance of it. But I think we're able to kind of answer that story to say, no, look, you really are getting value for that. I know that's a lot of servers that are doing nothing but compiling code all day, but you're getting value out of that, and here's what that value is.
The numbers sort of speak for themselves. They're staggering in their transformation, just 200% on 80,000 builds every 24 hours definitely is a number that is obviously unique to your environment, but just on their own merits, very impressive. What were the either scalability advantages or even issues that you solved with sort of the combination of the GitLab and the AWS architecture?
Yeah, we were in some ways victims of of that early success. We worked with our IT folks to stand up our initial GitLab deployment, spec'd it for 3,000 users. At the time, that seemed like an enormous number, and within 18 months, we were at 10,000. And so, we had to sit down and take a hard look at that and say, look, this is obviously becoming far more critical to the organization than even we anticipated. So we worked with the folks in IT jointly. We worked together with architects from GitLab and from AWS. And we said, look, what is the right architecture for this for the future? And it took time, in the order of several months, to really go through the installation of the new instance, to go through the hardening process to make sure that it really hit the scalability goals that we had for it. But I think the results of that were really astonishing just in terms of the reliability and scalability of the new architecture that we had. We moved from a system where the human beings, those individuals who are maintaining that system, would spend a significant amount of time doing upgrades, kind of bouncing individual servers when they would have issues, to a system where that is largely automated. And by the way, it's zero downtime to do upgrades. So, from the perspective of our developers, it gave them a lot of confidence that I can reliably put my code here because I know that it's going to be safe, it's going to be secure, and oh, by the way, if I do a git pull or a git push, it's going to work, right? It's not going to just be down for maintenance at the moment. And so that ability to demonstrate, hey, this particular kind of cloud native architecture, it does really provide the reliability and scalability advantages that it was promised. I think it gave our leadership a lot of confidence that, this group of software factory people kind of they do know what they're doing. And then also for our development community to be confident that it was safe to adopt.
Great. So again, I'm repeating myself a little bit, but the numbers do speak for themselves, but I'm sure that there are lessons learned. If you had to do this all over again, what would be the advice you would give this audience around the transformation effort, but also what you may sort of tweak or do differently as part of that transformation?
Yeah, I know, I haven't been terribly technical so far. I think a lot of the folks at this conference tend to be pretty technical, so I'll get a little technical for a minute. The current iteration of our common CI/CD pipelines, they are all based on containerized builds. We maintain a set of common container images that is in a Harbor registry. We also maintain a set of common CI pipelines that are pulled in to builds. Essentially every repository's GitLab CI file just includes half a dozen lines of boilerplate YAML to pull in the particular pipeline of interest. We are on our third iteration of that implementation. The first, and I will claim ownership for what I thought was a good idea. I had this notion of, hey, let me build like a wizard kind of interface. You click through, you kind of type in what you want for your project, you hit next a bunch of times, and at the end, you get a merge request automatically that merges a GitLab YAML file into your repository that provides the build. And the biggest struggle with that was it wasn't sophisticated enough for our power users, but it also wasn't simple enough for our brand new people, right? Like the brand new people are like, I don't know what to answer to a lot of these questions, but the power users were like, why are you forcing me into this box and why can't I just, do it myself? We moved on to an approach where we essentially had, called the great big repository of common CI. And that just quickly got unwieldy. It was great to have everything in a central location, but the versioning wasn't effective. The ability for people to contribute in a way that wouldn't inadvertently break everyone else's CI was just not there. So with the third approach, what we have is a catalog server. This is something that we knocked together ourselves with a little bit of Go code. And what it does is it reaches out to a set of Git repositories that are in the GitLab instance to pull in those common CI files. There's two big reasons why we do it that way. Obviously, GitLab supports just referencing other projects internally, just pointing to the location of the project and pulling in a CI file that way. But in our use case, there were kind of two things we needed. One was we wanted to provide some flexibility in terms of versioning. So in some cases, people can say, I want version 2 of a particular pipeline. And I don't care if it's 2.0.38 or 2.1.12 or 2.1.14. I just want it to use whatever is the latest major version, within that major version. In other cases, people are like, no, this is a specific customer release. I need to guarantee the replicatability of that build. And so I need to use exactly 2.1.14 of this particular pipeline because I need to know that a year from now it will behave in exactly the same way it does today. And so that's one thing that we get from having that kind of intermediate catalog server to choose the underlying version of the pipeline that it pulls through. The other thing that we get that is maybe a little more unique to our use case is the way that we do globalization or the way that we do kind of content delivery. So we have individual container registries, some of which are closer to our US instance, which has to run in a sovereign US space. It runs in AWS GovCloud. We have a global instance, but we also have other GitLab instances that run in sovereign regions in sovereign on-prem data centers in places like Canada or the UK. And for them, it doesn't make sense to transit all the way to the cloud to pull down container images. We also have GitLab instances that run all the way out in classified environments where there is no connectivity to reach back. And so things like rewriting which container image you should be using for all of the pipelines that are in the catalog, as opposed to having to do that as variables on a build-by-build basis. We felt like having something as a catalog server kind of sitting in the way would be beneficial to be able to make some of those smart decisions and have a little bit of intelligence there, in a way that was easier for us than just referencing the GitLab files directly. The key of all of that, because that was obviously a process that we went through, is that notion of kind of experimenting and iterating. Had we not set out, built it what was, arguably the wrong way first, we might not have gotten to the best way to do it ultimately. And it can be painful. It certainly was painful for us to say, yeah, we're going to deprecate this entire, wizard system with all of the intelligence and automation that we built into it, that, it got smart about the GitLab API and knew how to inject YAML files in a merge request. And, that was a good bit of code. And now we're going to throw it all away. But I think, it was definitely the right decision to do that. And I think the reason we knew that was the right decision is because we were listening to our users, right? And when they would come to us and they would say, like, okay, this is terrible. That's hard to hear, but I think it's also important to be able to listen to that. And I think that ultimately is how you get to be successful.
The feedback loop, for me, just hearing your story, I've heard it before, that feedback loop and the modeling from that feedback is my favorite part of your journey, because it's something that is not always, but it's something that is missing from a lot of transformation journeys. We talk about this top-down edict, and then at the end, 30 days later, there is success. But no, you're actually experimenting and getting feedback from your developers, and the fact that they can talk to you directly and give you that feedback is obviously part of why you've achieved the numbers you've achieved so far. I'm going to ask sort of an odd question that we didn't really talk about beforehand, but just because it came to me. I know you've mentioned before sort of the security and safety being sort of part of your objectives, where it's something you can't compromise on because of the mission critical projects that you're working on. How have you incorporated the security aspects from a cybersecurity standpoint into those development feedback loops that we talked about earlier?
Yeah, we are really fortunate to have a great partnership with some smart security folks within our organization. And one of the real advantages of this approach that we've settled on is that because we have these individual repositories that serve the various parts of our pipelines, we can actually be federated or distributed in the way that we manage ownership of those things. So from the very beginning, that security group just stepped up and they said, we're going to own the required security infrastructure, we're going to own the automation that runs within the pipeline in order to do static application security testing, in order to do software composition analysis, in order to do those essential stages of the security things that need to happen in the CI context, right? There's obviously security stuff happens everywhere, but that was the really important stuff in the CI context. And the result of that is, and they also on the backside of that, and this was maybe the best thing of the bunch, they were the ones fielding the developer questions of, hey, how do I integrate this into my build? Why is it, is your server down? Why isn't this working? And, that engagement between people who are really security experts by trade, but they picked up enough DevSecOps and CI/CD to be effective within the organization. I think they're kind of a model for what I would love to see security folks do everywhere. I think they were really powerful and effective because of that. They were willing to bring the solutions to the development community and kind of hit those people like within the context of the work that they were doing.
And just a small anecdote from my previous life, that bringing in of security folks into the architecture and design and daily operations has its benefits when there is an incident, because typically the worst part or the longest part of incident management is trying to find out what has happened, sort of doing that triaging. And having security folks that can speak to the design and what is going where and what is doing what within your architecture is a great resource for shrinking down that incident management lifecycle.
Yeah, that's really smart. You do not want to be explaining your architecture to the security engineer in the midst of an incident response.
Exactly. So far we've talked about your current state, and we obviously talked about the before states that got you to your current state. Can you just share with us what you're seeing as sort of 2024 and beyond? What are some of the future visions you have for your organization?
Yeah, I talked a little bit about the kind of moving global and the different sovereign regions, and we're excited with the direction that the cloud space is taking in that area, the potential for sovereign cloud regions that have kind of smart security controls for connectivity, so that folks that are working in Europe can, whether it's like in our case where it's more kind of military and export control regulations, but even if it's cases like differential regulations, like privacy regulations being different in different places, just to be able to guarantee sovereign processing of information in different parts of the world, I think is going to be a game changer for us. We are definitely also, like, I almost hesitate to say it because you've probably heard it 800,000 times already at the conference, but generative AI, I will drop the term. I would say though that we see it as, so first of all, we see it in two ways. Yes, are there potential efficiency gains? Absolutely, right? It's the reason everybody's talking about it all week is because that's exciting, and so it has the potential to affect how we do the work. I think it also has the potential to affect even those long-standing programs that we have out there for a long time. The defense business runs in many cases on paper, and in the case of engineering, we run on a lot of design documents that maybe have a long and storied legacy, and we really want to be able to bring those forward into the new model-based approaches that we're using for system-level design and development. And I think there's a lot of opportunity for generative AI to do that kind of work. From the perspective of our delivered products, there's a lot of opportunity for us. Many of the environments that our products operate in, they're inherently noisy, they're chaotic. Being able to tease the information out of the noise in those kinds of systems relative to what we can do today with deterministic algorithms. And so we certainly see opportunity there. But from the perspective of affecting the life of the everyday developer, I think I'm most excited about the idea of just a companion that operates alongside the experienced developer. I think that's the sweet spot for many of the code suggestion kinds of capabilities that we see. We can't, we still need that experienced person who can do the what DevOps calls systems thinking, that can think in terms of how does this small piece of code that I'm writing or generating, how does it plug into the broader complex system that it's a part of? We need some ability for the human being to visualize the system as a whole in order to understand, like, these are the parts of it that I can turn over to the AI and get some help in generating. And I think that combination of the engineer that can spend more time on the creative parts of the work that they do, while kind of delegating the dull and repetitive parts. I think that's how we've seen productivity gain in engineering in the past. Everything from the move from machine language up to higher level languages, or the ability to do modeling and simulation in software kind of environments. Taking away the repetitive parts of the job has really been how we've made progress, and I think that's definitely true for AI.
Yeah, I'm glad you mentioned Gen AI because I don't think we're allowed to leave the stage unless we say those words. So Thank you for giving us that permission. Yeah. Obviously, with all the work that needs to be done in the Gen AI space, or I don't want to call it transformation, but a lot of organizations need to go through some level of future-proofing before they start adopting some of the capabilities that Gen AI can bring to the table. What do you make of the comparisons that we have with what we have today with where we were maybe 15 years ago when cloud started coming to the scene, where people thought they could just lift and shift their current operations from where they were to the cloud without going through that restructuring or refactoring of the application to make them work in the cloud? Do you see those similarities with AI today?
I really do. I think that's exactly right. Generative AI is a game changer for organizations that have developed a certain level of maturity with the foundational parts of the software engineering lifecycle. If you have an environment, like we maybe had traditionally, where you have 1,000 different tool stacks, and you have 1,000 different kind of environments in which software is being developed, it's going to be hard to bring transformational capability to all of those environments. And you're going to get what we had back then, which was very much feast and famine. You had some programs that had just that right expert or that person that was passionate, and they had amazing capability, and then you had a lot of other programs that just didn't. And so I think that's one big difference. And then you created that analogy to kind of the cloud lift and shift. And I think that's really good as well, right? One of the things that we've learned in these early days of generative AI is that you need a really strong framework around the generated code in order to be able to make sure it's correct, make sure that it's secure, and if you don't have that, you're in an analogous situation to just picking up an on-prem server and just bringing it into the cloud, right? You're basically going to get exactly the same results you had before, but now in the cloud instead of on-prem. I think it's the same thing with AI. You bring generative AI into a software process that doesn't have really good test and security around it, then you're going to have software that's just as unreliable and insecure, but it was generated by an algorithm.
Yeah, that mirrors a lot of the same advice that we give our customers today around the whole DevSecOps movement, for lack of a better term. This unification of everything that you have to do across the entire pipeline is one of the best things you can think about for future-proofing your systems for AI, because all that cataloging, getting dev, security, and operations together, having policy as code, infrastructure as code, and scaling with a partner like AWS, all those things are still important for your AI transformation. So start now. If AI is on your bucket list of things you have to accomplish in the next few years to get that future-proofing done right.
Yeah, so we have a Lockheed Martin AI Center, and it's interesting because it's some of the most kind of DevSecOps experienced and capable folks in our organization, and I think that's a large degree of why they've been successful is they have that mindset. I think you'll see a lot more emphasis on ML ops, which is a term that's often used to describe. I have sat down with some really smart researchers. We have done a lot of work in Jupyter Notebook. We have come up with a model. We have, delivered that, we've done training in a, very complex environment. And now we have a thing now, like, how do I productize that? How do I make that part of a larger system? And, oh, by the way, if over time I want to refine and improve and fine tune that, how do I understand where it came from? How do I understand what the pedigree and provenance of all of everything that went into that model, not just the algorithm, but the data, but the training and testing data. I think you'll see more of an emphasis on that as companies move toward, really productizing things that are based on Gen AI or other kinds of AI or ML.
Great. So as we start to wrap up here, Alan, I know we've talked about a number of different challenges you've overcome, so that the toolchain complexity, the merger of two large organizations, forcing or be the forcing function for that collaboration and getting that feedback loop from your developers, and everything that you've done from a scalability standpoint with the well-architected framework with AWS and making sure the design was right. As we wrap up before we move to audience questions, so please use the microphone that is there to ask your questions. As we wrap up, if we could bring, or if you could channel one of your developers today and you're thinking about their productivity or efficiency for next year, what are some of the things that you feel how the development role will change as more of these tools become more commonplace?
Yeah, when I think about our developers and I think about, the person that tends to be in my head is the person who does spend a lot of time in a windowless room, in a basement somewhere, developing code because they work on a classified system. And, I think about the strides that we've made toward giving them a development environment and a developer experience that is close to on par with what we have in the unclassified side, but that we still have so much progress to go. And I think, I look at that and I think of the pace at which new tools and new capabilities are being made available, not least of which, as we were just talking about, our AI enablement. And how do we bring that to those kinds of spaces for us? I think to make that kind of a more general statement, for the person that's newly coming into your organization, how do you give them something that is kind of immediately graspable? This is how we develop software in the context of our organization, so they can be productive sooner. How do you create the kind of team collaboration so that the rest of their team can quickly bring them up to speed? I think, from my perspective, those are the kinds of things that I feel like we've made progress, but I feel like there's just so much more that we could do.
Great. Well, with that, Alan, thank you very much for the conversation, and thank you for the audience participation as well. Really appreciate the session, and enjoy the rest of your evening.
Thank you.